Good morning, everybody. A reminder about the Indaba coming up on the 27th to the 30th of July. And I would really seriously encourage you guys to try to attend. There will be a lot of topics that's being discussed, panel discussions regarding certain things in our industry, as well as new technology and things happening. And I think it's going to be a very exciting and insightful event to attend. So let me welcome Mr. Steve Brown and Mr. Richard Bailie. Morning, guys.
Morning, Gerrie. Morning, everyone.
Yeah, morning, Gerrie. Thanks, man.
Right, so let's jump in. The idea of this morning is basically we wanting questions from the audience. Any questions that you have regarding certain aspects. We will do a bit of a start off on a topic. But please, if you have questions, post your questions. Let's see whether we can get these questions answered and move forward.
And
so let's
also, just to jump in, this is not a lastminute.com, but unfortunately Adrian is unwell, who was going to present this morning. So we've just jumped in so that we can provide something today. So yeah, let's kick it off.
All right. Thank you for that, Steve. Guys, we just want to have a quick chat about a non-return valve. There's been a lot of audits that was done, or a lot of speculation in the industry regarding the installation of a non-return valve on a geyser installation. Now, if we have a look at the non-return valve, let's just have a look at the function. What does it do? A non-return valve, or one-way valve, is a valve that allows liquid to flow through it in one direction, but prevents its movement in the opposite direction. It prevents reverse flow or backflow. So that's basically the purpose of this valve. It's not anything else. So this is the flap type, or there's a couple of names for this one. And this is just to show you what happens when there's flow. Obviously, this thing, as you know, has got a little arrow in it to indicate the direction of flow. So in this direction where the blue arrow is, that will open that flap to allow the water flow to go in. And if there's opposite pressure, it will close it. So that's basically how it works. And the same thing with the spring-loaded one. So this is basically what it does and how it works and what it looks like on the inside. Then, once again, coming back to the myths, there is no requirement in terms of any sense code to install a non-return valve on a geyser installation. So we do get the situation where some of the people say, yeah, but this installation is not, because there's no non-return. That is not true. There is really no code that says you have to install a non-return. And the other thing is that some people think that a non-return valve, when you install it downstream from the geyser, creates balanced pressure. That is also not true. So we can expand on that, Richard. I don't know if you want to maybe get into this a bit.
Yeah, Gerrie, I think it's important to. I think there's two misconceptions, aren't there, for the non-return. Can you hear me, Gerrie?
Yeah, I hear you now. Thanks.
Okay, sorry. So I think there's two misconceptions for the non-return. The first being, you mentioned backflow. Now, backflow will or can occur between a tank, and you don't want non-potable water from the bottom of the tank being siphoned back into a main system. So you don't want the cold water siphoning back out from the tank in reverse back into the main system. So that is a problem, but that is taken care of by the anti-siphon loop. So the anti-siphon loop is there to prevent that. So the non-return cannot take that thing's place. That's number one. Number two is to rectify unbalanced pressure, an unbalanced system. A lot of guys think that by installing a non-return valve on the hot water line, that you have now rectified that situation. That's not the case. You simply put a band-aid over a bigger problem. And the only reason you're putting that non-return valve in that hot water line is as a manufacturer's recommendation, so that when you have an unbalanced surge or pushback at a mixing points. For example, hot and cold open at the same time. Cold overwhelms hot, pushes hot back, starts to overpressurize geyser, and PRV starts to leak. That situation is what the manufacturers want you to avoid. So they say, put a non-return valve in there. You're saving our cylinder and you're saving the PRV. But you've done nothing to change the fact that it's still an unbalanced system and it is still non-compliant. So please don't confuse alleviating one symptom of unbalanced pressure with correcting balanced pressure, because it's two completely different things.
Yeah, Richard, and I think the other one that we've seen, again, with the water interruptions that we have, and Durban apparently now is on water shedding, is that we've seen a lot of, even in the newspapers, where we've seen individuals where the geysers are back siphoning and everything else, and the solution's been is to put a non-return valve on the cold water inlet, before the geyser. And again, yes, it stops the backflow or the anti-siphon or the siphonage of the geyser, but what it does now is it voids the warranty on the cylinder because of the expansion relief. So again, it's just to have a look at the installation, and for those that I've seen, is to go and have a look at it and make sure that there's an anti-siphon loop, make sure the vacuum breakers are correct, etc., to avoid that back siphoning. But installing a non-return valve on the inlet of the geyser, is just a no-no.
Yeah. Also, Steve, just one other thing, if I may, Gerrie, just to mention,
Sure.
that that flap type non-return valve actually should not or may not be used in any potable water installation. So in the standards in 10252/1, it actually says that and I'll read it here. It says, swing type check valves with metal to metal seats shall not be used on hot and cold water systems in buildings. So just that's worth noting as well. And it's because I think, correct me if I'm wrong, guys, it's very prone to water hammer, is it not? And also it's not a perfect seal.
Yeah, correct. I mean, the water hammer is one of the main sort of reasons that you'll find, in terms of that where it creates water hammer.
Yeah, and I think also on top of that is also the fact that you will have a metal deterioration in that valve, which will obviously also go into the water, and that's most probably
Yeah, you could have damage to the seat or the flap.
Yes.
Yeah.
You also mentioned something about a ring feed with a pump system.
Yeah.
Yes.
Yeah, look, just staying on non-returns, I think it might be worthwhile mentioning the fact as well, because we're talking about non-return valves, that we must always bear in mind that a non-return valve, a single check valve, is not what we call, or what the standards define as, a backflow prevention device. So just always bear that in mind. And I know we're not talking about backflow prevention now. We're talking about check valves, but I just wanted to mention that a non-return valve is not what they call a backflow prevention device. And a backflow prevention device is something that is deemed appropriate or able or suitable to perform a backflow prevention function. And when they talk about backflow prevention function, it means we're talking about safety protocols now, preventing contamination of potable water. So the performance requirements jump from kind of wishy-washy to very specific. So backflow prevention device is something very specific. It is there to prevent backflow, which is there to prevent contamination of potable water, which means it becomes quite important, and it's governed, or not governed. It's supposed to be, it has to perform to better standards than just a single check valve can. So I just wanted to put that out there just for clarification. Yeah, you mentioned, yeah, sorry.
Yeah, so Gerrie, sorry to jump in, but I think the key thing is that, in terms of installing we're talking about hot water cylinder now, in terms of putting that non-return valve in. And, again, it does protect the cylinder. It is a protection device, but ideally, it would be to balance the system. But unfortunately, that sometimes becomes a huge cost. in terms of relocating valves and pipework and everything else. So it doesn't, like Richard says, it doesn't balance it. It just protects the cylinder and the PRV. So I think it's one of the key components is that, some insurers require it, and they're not wrong in terms of doing that, but it doesn't solve the problem.
Yeah, that's right. There's a question here from Colin. It says, I found that some check valves from a specific supplier vibrate and restrict the water flow. Yeah, you've got a spring with a plunger against a seat, and we all know, I suppose it's prone to all kinds of funny things, but strange that it should be vibrating to the extent where it should be a nuisance. But I've seen non-return valves with spring-loaded non-return valves on pumped loops, for example, perhaps a heat pump loop or whatever the case may be, where the spring pressure is too much for the pump to overcome. And that doesn't, so the pump doesn't flow or push it enough, or enough water flow. So it tends to create this vibration, and it sort of opens, then shuts, and opens and shuts very rapidly because there isn't enough flow. And in some cases, it actually stops the flow completely because the pump simply cannot overcome the pressure of the spring. And I've seen that a few times. So that is another consideration, whether or not the type of valve you're putting in, for whatever reason you're putting it in, is able to play nicely with the other kids in the playground, if you know what I'm saying.
Yeah, there's actually, if I recall correctly, there is, I actually read it yesterday, there's in 10252, they actually talk about this regarding pumps, and also your anti-siphon loop on the solar systems, where if your flow rate is not strong enough, you're going to have problems there. So you have to have a look at your pressure rates and your flow rates before you install this, to make sure that you're not creating a problem instead of solving the issue.
Yeah. And I think that's where the gauges come in, and very critical. We've spoken about it, and we've had the chap from Khalifi, Gordon come in, and Patrick Gordon. And, again, those pressure gauges and stuff tell a huge story in terms of the requirements and what you've got and how you can actually work around it, which will resolve that. So again, one of the key components to have in your toolbox, just to go and check that pressure rating, because that's one of the first things that we would ask if there's a water hammer or whatever, is what is the pressure? What is your static pressure, and what is it? And the guys don't know. So again, just one of those things to just add in your toolbox.
Yeah. Laurentius mentioning here, Khalifi non-return valve hull is very small, and again, I think it connects to what we just spoke about now. So it's all about, you need to make sure what's happening in your installation while you're working there, before you start just throwing components into the system that can actually create more problems than solve problems.
Yeah.
Richard, what were you talking about, that thing about the pump system? You made mention earlier about that.
Yeah, so I mentioned, Steve, if I may, or do you want to jump in? Do you want to say something?
No, carry on. We'll jump on to the other one after this.
So one of the things that I've actually come across twice in the last 2 months, I'd say, maybe 10 weeks, is where in a domestic setup there is a pumped circulation loop for the hot water supply. In other words, you've got a hot water source quite far removed from the furthest point or draw off point, and so you've got a supply and a return line, and that is linked to a pump, and that's okay. Now, I'm not going to go into how it should be designed in that, but the fact is that's a heat monster, a heat-eating monster, number one. So it's got to be properly lagged and properly designed and accessible and everything like that. And it must be pumped, but then you've got to control that pump. The pump has got to be controlled very carefully, either by differential temperature probes, or by timers, or by a combination of both of those things, or by any other smart means. Okay, but the point is, it's got to be thought out and designed and controlled properly. Now, I've come across systems twice now in the past 10 weeks where it's a brand new, beautiful, big home with a circulation system with 0 controls on the pump. And the intentions were good. So the intention was, well, let's put a pump in, let's put a return line with a pump, and what you can do, you can just switch this on, and this is what will result. The one was done as an afterthought. What that meant was that there was no lagging. So because the hot water reticulation piping originally was laid in the ceiling, it was lagged, but as it went down to various points in that, and there was a large portion of the loop underground, and it was not lagged. And so that's one thing. And number two, it wasn't controlled. So what you have is Mrs. Jones either switching on the pump and leaving the pump switched on for a month or two and not really realizing what they're doing, then wondering why their electricity bill is horrendous, or they become wise to it because they make a phone call and say, hey, what's happening? And oh, it's the pump, so let's switch it off. Then they switch it off and leave it off and live with the non-immediate hot water at the furthest point, but then start wondering why their water starts to taste and smell foul because they've got stagnant water in this loop. So a circulation loop in a domestic system is something that needs very, very careful installation, or at least design and installation. It has to be very carefully thought out, and the homeowner needs to know exactly what they're getting, and it needs to be controlled, and you must circulate that water regularly, and you must do it at the correct times. And I see it time and time again where this is just not done. So please, next time you come across a circulation loop, or you want to suggest that one is installed, just make sure that it's properly designed, because there's all kinds of pitfalls. I've seen it so many times in the last two and a half months. As I said, I've seen 2, but prior to that, I've seen many as well, where it's just not thought out, and it creates a hell of a problem for down the line. And the plumber's gone already, and the homeowner sits with that problem. I just wanted to mention that, Gerrie.
Sure. Okay. And then I see Bernardus is putting a comment here. I would recommend to install a flap type NRV on a pipe system, and maybe that connects to your thing that you were talking about just now, Richard.
No, well, yes. So that flap type, okay, we've already established that it's not allowed because of because the standards don't allow it. But no, a non-return on a pump system is not going to do anything. It's not going to create or solve any problems. Not the problems that I've shown now. Is the problem that I've come across is that the pump is not controlled. That pump must know when to switch on and when to switch off. In other words, it should have a differential temperature probe at the end of the run and at the heat source. And when that temperature difference reaches X, whatever, however many degrees you've chosen, it must kick in and circulate until that temperature difference reaches Y, and then stop. And so you can have this very careful, controlled circulation, ensuring that there's hot water at the last point, but also ensuring that you're not using tremendous amounts of electricity. And also you can couple that to a timer so that that pump is off completely between certain hours. So in other words, it can be set up to time to pump only between 5 p.m. and 10 p.m. when everybody's home and wanting to use hot water in that. Then for the rest of the day it's off. Fine, no problem. That's controlled, and you're controlling it. But in situations where you've got a pump that is simply running 24/7, not only the electricity for the pump, but also the constant flow of hot water and heat loss through that loop, constant 24/7. And on top of that, if it's not lagged, then you on a hiding to nothing.
Yeah, and I think maybe important is to once again to understand that the flap type is not to be used on a potable system. So, Bernardus, maybe you must just rethink your plan regarding that. Okay, so then Colin here says, so if I do a solar siphon, I doubt the spring valve would work. Well, once again, I think that would depend on the pressures and the flow rates that you have in your system. So you need to test it to make sure what is the situation there. And Richard, correct me if I'm wrong, I think in the SANS 10.6, it actually describes the use of a non-return and anti-siphon loop. Maybe you can give us some more info there.
Yeah, Colin mentioned solar siphon. I must just clarify what exactly he means there. On a thermosiphon system, on a solar, you don't use any non-return valves or anything else in the loop at all. But if it's a pumped system, so it's not a thermosiphon system, the panel is higher than the tank, then you have to put some sort of a non-return valve in next to the pump so that the reverse thermosiphon doesn't occur, because at night when the panel is cold and the water is hot in the tank, all that hot water wants to travel to the panel and it will dissipate the heat, and that flow, that reverse thermosiphon will occur. So you have to put a non-return valve in there. So you need to choose that non-return valve in conjunction with the power of the pump. So the pump must be able to overcome that non-return valve spring pressure during the day when it is pumping, yes. So that you can use spring type valves, but they need to match, or that needs to be compatible with the pump. I've seen many spring type valves used and it works perfectly well.
Yeah, and I think that connects to Louis Bosman's question. If you have a 12-volt pump that runs off a 10-watt panel, what is seen as controlled? So I think, Richard, you just answered that question.
Yeah, not sure if that pertains to solar geyser or the hot water circulation, because it's two completely different things.
I would assume that's your circulation loop to the collector.
No, Gerrie. No, because we're talking about solar. Two things. We're talking about two different things. We're talking about a hot water circulation loop in the property.
My assumption here is that split system to ensure circulation to the solar collector, sorry.
Well, if it is to a solar system, then you can argue that is controlled, yes.
But I think the other thing is, and we're going to go back to what you were talking about circulating the hot water distribution in a fairly sizable house. The biggest challenge that we have is that, the problems normally arise when it's finished. And I think the key thing for me, and I've seen many of those, is try and get that information before you start. As you're saying there, Richard, you've got a pump that's running 24/7, you've got all of these things. And I think the key thing is that, is to go out and ask the questions, go and have a look at the flow rates, the distances, what's required, etc., because it is sometimes very difficult to go and start rectifying these installations when we actually haven't gone and ask the right questions in terms of the design. And there are individuals that we can call on, to assist and guide with regards to these, to alleviate the problems that we experience when the house is handed over or the dwelling's handed over. It becomes a challenge.
Yeah, 100%. So all that good communication and design work and that sort of, those discussions must happen at the plan stage. When the things are on the plan, you're sitting around a table and you're discussing how to install this plumbing.
Correct. And I think that's the key thing, is that, like all men, we don't like to ask for directions, but I think the key thing here is that there are individuals that can direct us to the right way and how to do things. And that, alleviates a huge amount of pain and suffering, and it has a positive impact on your bank balance, rather than having the pain and suffering and the botheration of a client who built a massive big house, who wants to have hot water, and it becomes a challenge. The other thing, guys, is that, what we've seen, and I know we don't like talking geezers, but, again, I've seen some very proactive plumbers, here in Durban especially, where, that non-compliance in terms of high-rise buildings, where they're taking geezers out, putting them back, and bringing it to the attention of body corporate. So a couple of weeks ago in Durban, we had a situation where the plumber, again, being very proactive, and calling in for assistance and guidance to meet with body corporates in terms of the discharge from TP valves and expansion reliefs. And in this particular building that we looked at, we did, I think, an inspection of about 10 or 12 units. And, we had geysers with no trays. We had them, a hole drilled into an SV pipe, Pratley's putty, etc., etc. And I think, meeting with the body corporate, and we brought in an engineer, who's now doing a design for the building in terms of making it compliant, or is doing a rational design to do it. And I think that's really positive when you start to see the plumbers, applying the principles of what the standard requires, and taking into consideration the health and safety of the consumer. But I think the key thing for me is we've seen it over a bath, for example, the TP will come down, discharging over bars. And again, if we can't get it compliant, then it has to be safe. And I think that's one of the things that I've seen in the last couple of weeks is that, just signing a non-compliance notice and saying, well, it's discharging over the bath or a shower or whatever, is not the way to do it. The responsibility is to try and make it as safe as possible, and take it into a PVC trap or a PVC pipe is certainly not going to meet those requirements in terms of health and safety, or for that matter, in terms of the discharge being able to be visible and seen and without causing damage. Barry Chapman and Bailie showed us one where the TPs were discharged into a sewer system. And when the TP went, it destroyed like 20 odd meters of sewer in the ceilings. So again, it's just to start thinking about those things. And again, there's an opportunity. I mean, this plumber is now, at the forefront because he's brought it to the attention of the body corporate. And they were asking the questions, well, what about the other plumbers that have replaced these geysers? Why haven't they raised it? So between IOPSA and a meeting on site and just reiterating that. And I think it's something key that we need to do.
Yeah, Steve, I came across one or two of those as well. I was asked to come and look at a very, very similar situation. I think there are probably 300 or 400 units in multiple blocks of flats in this one complex. And the plumber had done exactly that. He had notified, and it had taken like 6 months of him nagging the body corp to say, hey guys, every time I replace a geyser here, I tell you this, and you're not taking notice of me. You're not taking notice of me. And eventually they listened and they said, okay, what is your solution? And he came up with a solution, and it was like a 1.5 bar and they said, Achman, you're ridiculous. That's crazy. So I said, okay, allow me to call in IOPSA. And they did. And we came in and we said, and we concurred with him. We agreed with him. And their eyes opened up. And so it shows you that if you just do the right thing, and to beat that drum for the right reasons, doing the right thing, eventually some doors may open. And I mean, that guy got that contract, and he's installing cast iron downpipes along the outside of all these units and running TP valves to them. Well, he's not running the TP valves to them because that was deemed for the individual owners and units accounts, but he's running the cast iron downpipes down the sides of the buildings with branches and ton dishes, and allowing them positions to discharge these TP valves into. And that's a hell of a big contract, and it came from a bit of pressure from his side and repeated pressure. So yeah, exactly the same thing, Steve.
Yeah, and I think it's something that, again, I'm going to just bash the same drum. If we are proactive, in terms of how we go across it, it's just no more than just giving a piece of paper and walking away. In this particular block, the body corporate were sort of negative in terms of, pipes discharging in those positions and drilling holes through walls. But, it came from, well, the body corporate's making decisions for the owners and in terms of damages, who was going to be responsible, for geysers that failed. And eventually the insurer sort of endorsed policies to saying, well, look, we're not going to cover resultant damage anymore, and find a solution. And I've got to be honest, as difficult as things are, there's always a solution to try and either do a rational design or bring it together. But in this instance, kudos to the plumber, and your guy. We're standing up and saying, well, get IOPSA involved, come along. We've got the personnel and the people to be able to assist and guide and substantiate the allegation or what you've raised with the consumer. And that's a positive of note.
Yeah, Steve, if I can maybe connect to that, I've had quite a number of these types of situations recently, where the plumber has tried to advise the body corporate or the people, even the owner of the house, and he says, you're just saying this because you want the work. Now, I think a good connection point here is, as an IOPSA member, We do help with these to advise, and people tend to listen when there's an IOPSA representative there to give guidance. So maybe that's just another thing to think about.
Yeah. All right, gents, I think we're out of time now. Richard wants to go back to bed. Thank you, Gerrie. Thank you to all those in attendance today for being here. We hope that it was a little bit informative, and yeah, we're off to do some training today in KZN. We've got 40 installers training today, so we've got quite a good setup going on today, and yeah, we look forward to it. Thank you very much, everybody. Take care. Have a wonderful day.
Thank you, everybody. Stay safe. Keep well.